Another technique is multi-RAT internetworking. RAT is radio access technology. Once again, we have the millimeter wave, and also we have above 6 gigahertz, which were many frequency bands, and below 6 gigahertz, which were many frequency bands. That means that we need to mix and match among multiple radio access technologies and provide internetworking services. So the UE and the network-based multi-RAT coordination technology is definitely needed. Throughput and connection reliability enhancement using licensed and unlicensed spectrum coordination is required. Unlicensed, what do you mean? Well, think of it like this. For the 2.4 gigahertz band, which is the IMS band, which is used for Bluetooth, Wi-Fi, Zigbee, and other devices, this unlicensed band, as well as the licensed band, which are dedicated for LTE or 5G communications, you need spectrum coordination. Looking into unlicensed and licensed bands listed together, look at the LTE at 800 megahertz, 2.1 gigahertz, and then 3.5 gigahertz. These are licensed bands. And then unlicensed bands at 2.4 gigahertz for Wi-Fi, the ISM band. Also in that region is where Bluetooth and Zigbee and other devices use. Then over here in the Wi-Fi range, this is also the 5 gigahertz unlicensed band. But in this range also a licensed technology like the LTE, LAA, the licensed assisted access could be using it as well. Then 5G technology frequency access needs to be added here, which will also include below 6 gigahertz and above 6 gigahertz, which include the millimeter wave technologies as well. So you need multi-radio access technology, multi-RAT internetworking, and that will support the coordination such that you are using different bands in a very intelligent way to provide broadband access in a seamless manner. Internetworking and integrating the 5G system with other radio access technologies, 3G, 4G, Wi-Fi, Bluetooth, is needed. Multipath transmission technology enables a device to use multiple transmission protocols simultaneously for cellular, like 2G, 3G, 4G, as well as wireless LAN, like Wi-Fi, Bluetooth, and other techniques can be used together where I'm connecting both the Wi-Fi access point as well as the millimeter wave base station. This could be done simultaneously using multipath transmission technology based on multi-RAT internetworking. Then, we need to consider that multipath transmission enhances connection reliability and data transmission rates at the cost of higher technology coordination. The MPTCP, like multipath TCP, enables a device to configure several TCP sessions simultaneously by using multiple network connections and addresses. This is what could be run on a multi-RAT internetworking technology supported 5G network. Advanced MIMO technology or MIMO technology, where MIMO is for multiple input, multiple output. You're using multiple antennas, and you want to take advantage of diversity mode. There's time diversity, frequency diversity, and space diversity. Time diversity wise, you're using different time slots and channel coding. Frequency diversity wise, you're using different channels and modulation techniques. Of course, some things like spread spectrum, OFDM, OFDMA, and MIMO combined techniques. Space diversity is about MIMO technology using antennas located at different locations or positions. They need to have a certain amount of separation in distance, like a couple of wavelengths of a difference, but they can be placed even closer if you have them in certain positions that they may be orthogonal and not influence each other's signal patterns. So uncorrelated radio paths are simultaneously used with multiple antennas based on space diversity. Then you need to consider how you're going to use space diversity. What are the antenna positions as well as their distances, and you consider that in your design and use that to your advantage to get full capacity of using the MIMO technology. We also need to consider multiple access where OMA, orthogonal multiple access, and non-orthogonal multiple access, NOMA, going into the details, well, in OMA, each time or frequency resource block is exclusively assigned to one user, like we did in OFDMA. However, in non-orthogonal multiple access, this allows multiple users to share the same time and frequency resource. So in other words, if you had a certain frequency division and also a time slot assigned, with intelligent NOMA techniques, that could be adaptively shared to enhance the system capacity and accommodate massive connectivity. In other words, even though a certain time slot was assigned to a certain user, if you can reuse that locally in a short-range communication device that you will not interfere with the overall usage of that time slot and frequency slot that was assigned to another user in a different location, then you can maybe intelligently reuse some of the time slots and share it. This is almost like using cognitive radio technique based on mobile communication platform in a multiple access structure based on NOMA technology. Pretty cool. Advanced device-to-device communication. Now, normally devices need to connect to the radio access network, which is connected to the core network. So you're going to eventually need to use some part of the RAN as well as the core network CN. But through device-to-device communication, since we're considering such high data rates, in addition, since we're considering such massive ultra connectivity for IoT devices, like through the MTC, where we have like 1 million of devices in a square kilometer area, well, maybe we could use our network a little bit more efficient such that if the device is in range with me and I do not need to use the eNode B or the radio access network resources, if there's a way I can directly connect with devices to get service support and avoid using dedicated resources within the RAN and the core network, then maybe I should through D2D technology. So you want to offload data from the mobile network such that the load and cost of processing data and signaling is reduced. Here, one of the critical things is MCPTT. Before there was PTT, that was push-to-talk. Think of a walkie-talkie. Walkie-talkies use a common band, and when you want to say something, you push the button and then you talk. That is what we call PTT, push-to-talk. In a more advanced mode, we have mission-critical PTT. And that is what we are talking about in advanced D2D in 5G NR techniques. V2X, which is vehicle-to-anything communication, could be another place where advanced D2D technology could be very effective. The standards, where you see IEEE 802.11p and the IEEE 1609, these combine to create the WAVE protocol, wireless access for vehicle environments, WAVE, W-A-V-E. Adding on cooperative computation support for V2X communication could be what advanced D2D through 5G NR could be effectively supporting. Efficient exchange of emergency signals between vehicles and roadside units could be supported through this. Advanced small cell technology, like in the HETNET technology and SON, self-organizing network supported technologies, in 5G mode is also needed. Large number of small cells in a given area can provide significant throughput enhancements. 5G systems utilize vast bandwidth in millimeter wave bands, and these are what need to be included very intelligently and scheduled effectively in 5G wave techniques. High propagation loss of the millimeter wave makes it suitable for dense small cell deployments. So, distributed and self-configured network technology using SDN and NFV would be very effective here. And this would make it very easy to deploy small cells. These are the references that I used, and I recommend them to you. Thank you.